source or the air conditioning pack. Conditioned air for the flight deck and cabin is supplied either by a ground air conditioning source or the air conditioning packs. The two identical air conditioning packs use pneumatic bleed air from the engines, the APU or a ground pneumatic source, to provide heating and/or cooling air for environmental comfort and pressurization. The air conditioning packs and the pack controllers constitute the basic components of the 767 environmental control system. A number of subsystems, including a mix manifold, recirculation fans, trim air system, compartment temperature controllers, shoulder and foot heaters, equipment cooling systems, and cargo compartment heating systems complete the system. You can click the subsystems above for a brief description of each one. The packs are controlled by their respective pack control selectors. Positioning the selectors to auto or one of the standby modes sends an open signal to the respective pack flow control and shutoff valve. The auto position is selected for normal operations. Note: the pack flow control and shutoff valves also require air pressure to open. There are 3 zones in the aircraft. Each zone has its own temperature control. With a pack selector in auto, pack output is automatically maintained at the temperature requested by the coldest zone. The other zones requiring a warmer temperature have warm trim air added to the cooling air to maintain the compartment selected temperature. For example, this frame shows the trim air not flowing to the flight deck because the requested temperature for the flight deck is colder than the requested temperature of the other zones. While the actual temperature of the forward and aft cabin zones is displayed at the top of the panel, the desired temperature can only be determined by the relative position of the zone temperature selector. In review, the packs output a temperature equal to the zone requesting coldest setting. In this example, the flight deck zone and the remaining zones are warmed as required by the trim air system. The standby mode is a manual temperature control mode. It is used for non-normals. With the pack selector in standby, the respective pack output temperature depends on which position is selected. Located just above the pack control selectors are the pack reset switches. The reset switches can be used to reset the pack temperature controller to operate after certain non-normals have occurred. These switches also have 2 indicator lights that alert the crew when a pack malfunction exists. The pack off light indicates that the pack valve is closed. The pack valve could be closed because the pack control selector is off, a pack trip has occurred, or there has been a loss of supply air to the pack. Either way, the pack off light indicates no airflow through the pack flow control and shutoff valve. For example, if the supply of bleed air is too hot, an overtemperature condition can close the engine bleed valve and therefore cut off the airflow, and this will cause the pack off light to illuminate. The inoperative light illuminates when the temperature output of the pack is too high or there is an overtemperature condition in the pack. The inoperative light will also illuminate due to a failure of the automatic temperature controller. When the inoperative light comes on, the pack will not necessarily shut down. We will now discuss 3 different conditions that will cause the inoperative light to illuminate. Pack outlet temperature too high. The first condition is a high pack outlet temperature. When the pack outlet temperature exceeds a set value, the inoperative light illuminates and an ICAS advisory message of left or right pack temp is displayed. The pack continues to operate, but its temperature control is automatically set to the full cold position. To maintain the desired temperature control, the pack can be operated in a standby mode. The inoperative light should extinguish when the pack output has cooled. After cooling, the pack can be reset for resumption of automatic operation by pushing the reset switch. If the inoperative light is out, the pilot can select Auto if automatic temperature control is desired. Pack overheat. The second condition is an overheated pack, such as high compressor outlet temperatures. The result is that the pack automatically shuts down. When this situation occurs, the inoperative light comes on, the pack valve closes, and therefore the pack off light illuminates. ICAS displays an advisory message of left or right pack off. Pack auto temperature controller fail. The failure of the automatic temperature controller will initially appear like the condition with the excessive pack outlet temperature. Again, the pack continues to operate, and only the inoperative light illuminates for this condition, with ICAS displaying the same left or right pack temp messages. Whereas the temperature control valve moved to full cold in the condition with high pack outlet temperatures, the temperature control valve freezes in the existing position when there is a failure of the automatic temperature controller. As with the excessive outlet temperature condition, temperature control can be restored by switching to a standby mode. In this case, the inoperative light extinguishes upon selection of the standby mode. The fact that the inoperative light extinguished when the standby mode was selected, in example, auto mode turned off, was your indication that the condition was a failed automatic temperature controller. When the automatic temperature controller has failed, the pack cannot be reset for automatic temperature control and must be operated in a standby mode. Review. We will now review the three conditions that cause the inoperative light to come on. With the inoperative light on alone, there is either excessive pack outlet temperature or a failure of the automatic temperature controller. If upon switching to standby the inoperative light goes out immediately, your problem was the controller. Reset is not available. Manual temperature mode must be used. However, if upon switching to standby the inoperative light remains on, your problem was excessive outlet temperature. After cooling, the reset should restore automatic temperature control if you also select Auto. If the inop light and the pack off light come on together, the pack has shut down, probably due to excessive temperature inside the air cycle machine. Remember, always refer to your QRH for specific procedural information. Two switches located on the left and right sidewalls provide the pilots with independent heating for the shoulder and feet areas. The shoulder heater switches turn on electrical heaters that heat the conditioned air flowing to the side windows. The foot heater switches turn on electric heaters in the floor. The heaters are available only in flight. Zones for the airplane is divided into 3 compartments, zones for temperature control. Flight deck, forward cabin, aft cabin. 2 compartment temperature indicators on the aft part of the air conditioning control panel display the current zone temperature sensed in the compartment. 3 compartment temperature control selectors are provided. The flight deck temperature control selector controls the temperature to the flight deck. The forward cabin and aft cabin temperature control selectors control the temperature to the forward and aft zones respectively. The auto position provides automatic temperature control to the associated compartment. The flight deck temperature controller has a man position, providing manual control of the flight deck temperature. The switch is spring-loaded to the 6 o'clock position. Holding the selector towards C, cool, or W, warm, drives the compartment trim air valve to the selected direction. The temperature range for each controller is 65 degrees Fahrenheit, 18 degrees Celsius, and 85 degrees Fahrenheit, 30 degrees Celsius. During automatic operation, the desired temperature for each compartment is set on the respective compartment temperature control. The existing compartment temperatures and desired temperatures are sent to the cabin temperature controller for processing. The temperature controller signals the pack temperature controllers to produce conditioned air, which satisfies the compartment requiring the coolest temperature. Note that the other compartments may require warmer air. The trim air system supplies hot bleed air to adjust the temperature for these other compartments. The bleed air is taken from the pack supply duct just downstream of the pack flow control valve and is used to mix with the air from the mix manifold to raise the temperature in the other compartments. In the above example, the compartment temperature controls regulate the amount of hot air to be added to increase the temperature for the forward and aft compartments respectively. A trim air switch controls the trim air flow to the compartment temperature controls. The normal position of this switch is on. With the trim air switch on, the actual position of each trim air valve depends on the selected temperature. Pushing the trim air switch to off turns off the trim air flow and causes all compartment temperature controller in-op lights to illuminate. When trim air is off, the cabin automatic temperature controller attempts to maintain all compartments at approximately 75 degrees Fahrenheit, 24 degrees Celsius. When trim air is on, the in-op lights are normally extinguished. Moving a single temperature selector to off will turn off the trim air for the zone, and the associated in-op light will come on. A single in-op light indicates either the forward or aft zone trim air is selected off, or there is a malfunction affecting an associated temperature control system. Therefore, the in-op light indicates either, see above. An ICAS advisory message of flight deck temperature, forward cabin temperature, or aft cabin temperature accompanies the in-op light to indicate the above conditions. Normally all temperature controls are set within the auto range. Movement of the flight deck compartment temperature control to manual allows manual control of the compartment trim air valve. The 6 o'clock position is spring-loaded. Holding the control toward the C position closes the trim air valve, but holding it towards the W position opens the trim air valve. Valve position can be monitored on the flight deck trim valve position indicator. A ground source of conditioned air can be directly plugged into the mix manifold and distributed from the mix manifold into the aircraft. Obviously, any temperature control has to be made on the external ground conditioned air cart. Engine operation, pack operation. On the ground, engine operation, pack operation, air-ground logic, airplane skin temperature and ambient temperature are all factors that determine system configuration. A supply fan and exhaust fan either recirculates cooling air back through the system or ports it overboard. In flight, only the exhaust fan operates, and the air is recirculated through the system.
On the ground, before engine start, and with temperatures above 45 degrees Fahrenheit or 7 degrees Celsius, the inboard supply valve and the overboard exhaust valve are open, and the skin heat exchanger valve is closed. Both fans operate. Inside cooling air is used to cool the equipment and then exhausts overboard. After both engines are started, the skin heat exchanger shutoff valve opens, the inboard supply and overboard exhaust valves close. This configuration circulates air through the skin heat exchanger using both supply and exhaust fans and allows for the cabin to pressurize. In flight, the inboard supply valve and overboard exhaust valves are closed, the skin heat exchanger valve is open, and only the exhaust fan operates. However, the supply fan will automatically operate if the exhaust fan should fail. The overheat light illuminates if a failure occurs in the equipment cooling system. In this situation, the crew will select Standby. Standby configures the system for inside circulation and provides flow from the supply fan. With Standby selected, the overheat light is inhibited for 5 minutes. If the overheat condition remains beyond the 5-minute time period, the overheat light will again illuminate. If the overheat light illuminates 5 minutes after selecting the standby mode, selecting the override mode will deactivate the overheat light. With override selected, the air conditioning manifold valve is moved to provide direct flow of conditioned air for cooling of the equipment, and the smoke override valve opens to provide an exhaust path. Notice the flow of air in this situation. The inboard supply valve and the overboard exhaust valve are closed, as is the skin heat exchanger valve. A smoke detector is installed in the system. Detection of smoke will illuminate the smoke light. The non-normal procedure directs the crew to select override to direct the air-conditioned airflow as described beforehand. Therefore, the override mode is used when smoke is detected or when the auto and standby modes do not provide equipment cooling. If no reverse airflow is detected in the override mode, after a 1-minute delay, the no cooling light illuminates, and if on the ground crew call horn will sound. When the no cooling light is on, the ICAS caution message will display forward equipment cooling. In this situation, certain equipment not powered by standby buses is subject to imminent failure, while equipment powered by standby buses is reliable for 90 minutes. However, essential avionics and other electrical equipment cannot be relied upon beyond 90 minutes when the no cooling light is on. Finally, you should know that the valve light and an ICAS message of forward equipment valve is displayed when any supply or exhaust valve is not in the commanded position. When this light is on, the crew will normally select standby to configure the system to the inside closed loop mode. If the valve light remains illuminated after 30 seconds, the pressurization system may not operate properly because the overboard exhaust valve may not be closed. The 767 has 3 control switches. The cargo heat on the 767 has 3 control switches in the cockpit. Each switch controls a shutoff valve for cargo heat to the respective compartment. Now, cargo heat is provided to the aft and bulk cargo compartments from the center pneumatic duct. Cargo heat is provided to the forward cargo compartment from the pneumatic crossfeed duct. With the switch selected to on, the associated shutoff valve opens, and with the switch off, the shutoff valve closes. The downstream control valve automatically opens to maintain the cargo compartment temperature at or above 45 degrees Fahrenheit or 7 degrees Celsius. Therefore, with the switches on, the cargo compartment temperature is automatically maintained at or above 45 degrees Fahrenheit or 7 degrees Celsius.
The cargo heat overheat light illuminates in the event of a cargo compartment temperature above the standard control range, triggering the ICAS advisory message, forward, bulk, or aft cargo overheat. In this case, the associated cargo heat shutoff valve is signaled closed.
The cargo overheat condition and indications will automatically reset. Now, if the control valve fails in the open position, the system will most likely cycle on and off at the limit temperature. The crew will determine whether to allow the system to cycle depending on the type of cargo in the associated compartment. Since live animals need warmer temperatures than the 45 degrees Fahrenheit or 7 degrees Celsius normally provided by the standard cargo heat system, the bulk cargo compartment has a bulk cargo heat selector installed on the accessory panel. With the bulk cargo heat selector in the normal position, cargo heat operates as described and no cabin ventilation is provided to the bulk compartment. With vent selected, a fan comes on to circulate cabin air through the bulk compartment and to raise the temperature to a minimum of 65 degrees Fahrenheit or 18 degrees Celsius. Now this ventilation air then exhausts from the compartment and flows to the cabin outflow valve. Therefore, the vent position is required when live animals are carried in the bulk compartment.
The Boeing 767 freighter is equipped with air conditioning and ventilation systems for the forward cargo compartment. This module describes the operation of these two independent systems. We begin with the forward cargo ventilation. The forward cargo ventilation is provided by an exhaust overboard valve that is normally open when both packs are operating and the airplane is in flight. There are no normal procedures for the flight crew that relate to this system, and the flight crew has no direct control of this system. As stated previously, the forward cargo ventilation valve is normally open in flight, but the valve will automatically close if one or both packs are not operating, or the equipment cooling selector is in override, or the airplane is on the ground. The forward cargo air conditioning panel is located as shown and is described later. The fault light on this panel will illuminate, and the ICAS advisory message Cargo Ground Exhaust Valves will display if the exhaust valves fail in the open position. The flight crew will refer to the appropriate non-normal procedure in this condition. This completes our description of the ventilation system. Now, let's learn the air conditioning. The forward cargo air conditioning system is supplied from the left air conditioning pack, and bleed air is used to provide temperature control as necessary. The bleed air is warm and can be used to raise the temperature from the left pack, but the temperature to the forward cargo compartment can never be more cold than the temperature from the left pack. The forward cargo air conditioning panel has 2 amber lights and 1 temperature control. The control has an off position, which is selected to turn off the forward cargo air conditioning system. When the control is in any other position, it is in the auto range, which turns on the air conditioning operation and allows for selection of temperatures from cool to warm. The current temperature in the forward cargo compartment is displayed on the ICAS status page. The flight crew can monitor this temperature and make the adjustments with the temperature control as necessary. Note, a temperature below 45 degrees Fahrenheit or 7 degrees Celsius requires selecting the forward cargo heat switch to off. The forward cargo air conditioning also has an automatic backup mode. When the backup mode is active, the fault light comes on and the ICAS advisory message, Forward Cargo Backup, is displayed. The backup mode automatically activates if normal operation has failed, and its purpose is to help keep the compartment temperature as close to the selected temperature as possible. It may be necessary to make a manual adjustment with the temperature control to maintain the appropriate compartment temperature in this situation. Use this page to review the 2 ICAS messages that will cause the fault light to illuminate. There are also 2 ICAS messages that can cause the ANOP light to illuminate. Here we show the ANOP light on and the ICAS advisory message, Forward Cargo Air Conditioning, displayed. These indications appear if the forward cargo air conditioning fails, or for any of these other conditions. Either pack valve closed, either engine bleed valve closed, forward cargo conditioning shutoff valve failed closed, auxiliary zone controller failure, forward cargo temperature selector failure, or arming of either cargo fire switch. We now show the ANOP light on and the ICAS advisory message, Cargo Air Conditioning Control. These indications appear if the forward cargo air conditioning controller fails. Use this page to review the 2 ICAS messages that will cause the ANOP light to illuminate. This completes our description of the forward cargo compartment air conditioning and ventilation. Now for the questions.